Okay, so this is a review on solving a synthesis problem. And so before we begin, though, let's look at some of the reactions that are important for us to go over for this particular synthetic strategy. So we can see that we have an aldehyde, and it says that we're going to start with acetylene. And so we need to remember a few reactions involving alkynes. The first one is, how do we get an aldehyde from an alkyne? Well, we can use hydroboration to do this for us. And so we can use BH3 and THF, followed by a subsequent reaction with hydrogen peroxide. Now, remember that this reaction gives you initially as an intermediate what we call an enol, which you can see drawn here, which then subsequently will tautomerize over to the aldehyde. So we don't actually isolate the enol, we isolate the aldehyde, and so this is how we get from the alkyne all the way to the aldehyde. So we can tell that we're going to be using this guy during this reaction since we have an aldehyde. And the other reaction that's going to be very important for us is how we can use alkynes to make carbon-carbon bonds. Right? So we need to connect two carbons together essentially, and we can do this from an alkyne by making what we call an acetylide anion. So here's just an alkyne, and we can see that if we treat this alkyne here with a strong base, so something like sodium amide here in ammonia, and what we notice is that we form our anion that you can see being drawn here. Now this anion, what is very important to note about it, is that it can become a nucleophile, and this guy can be a nucleophile in an SN2 type reaction. So if you remember what an SN2 reaction is, we have some nucleophile that attacks an unhindered carbon that has a leaving group, and so we can use, say, some kind of alkyl halide. So let's just do bromoethane, and you can see that we can make the connection by undergoing this reaction to give us now our carbon-carbon bond, whereas we have our alkyne that is now connected to our what was our bromoethane and now just the ethyl group that we have at the end. Okay, so since we have finished looking at some of the reactions that are going to be necessary for completing this synthesis, let's look and see how we go about solving it. And the way that we really want to do this is what we call using a retrosynthetic analysis. So what that means is, in a sense, we're going to work backwards, starting from the product. And so if you look at the product, keeping in mind what we talked about from the reactions, you can see that there's an aldehyde, and so this aldehyde then must come from the alkyne that we have. Now remember, we had to start with acetylene, which is the simplest alkyne, right? So let's use this process now. Since we know where the alkyne was, let's use this process to work backwards in our retrosynthetic analogy. So, or analysis. So if you notice here, there's an arrow like this. This is what you use for these retrosynthetic arrows. And since we know that aldehyde came from the alkyne, we're just going to now just draw in our alkyne here because we know that we can use BH3THF, right, to go from that step over to the next one. So now we just need to connect the other pieces. So we also remember from when we talked about reactions that we can use a carbon-carbon bond coupling, right, using the acetylide anion. And so we can see that we just need to put on something that can be coupled, and here we just need some leaving group that's attached there to make our carbon-carbon bond, and now we've broken it down all the way to our acetylene. So now, all we really need to do is just put this guy together, right, starting with acetylene to give us our final synthetic pathway. Right, so we're going to start with acetylene here. So here's acetylene, and we said that we could use sodium amide, right, a strong base in liquid ammonia. And so this is going to give us our acetylide anion. And we can use this in the corresponding SN2 reaction. We already have it broken down, so we'll just add a bromine there on the end for our leaving group. You can use an iodide, whatever you would like. And now you can see that we've made our connection. We're pretty much halfway done with the synthesis, or almost all the way done. We just have one more step. And the other step that we're going to do is, of course, our BH3THF, or step number 1 there. And then, of course, we need to follow that up with our hydrogen peroxide to actually give us the alcohol. And you can see that now we have formed the product there that we initially set out to form. So we've used the acetylene to start with, and we formed our desired product. Hope this helps, and thanks for watching.